but it's this sterile inflammation that it wreaks havoc in your body and causes all the age-related diseases. So every age-related disease you can name, heart disease, cancer, diabetes, dementia, and more, autoimmune disease, obviously, are all related to inflammation.
This is the first time, I think, in a book that you've tackled the topic of longevity.
For sure.
So what do you have to teach us, Dr. Hyman?
So much.
About longevity.
So much. And it's really an exciting moment because aging has been a neglected area of medical practice and research for all of medical history until really recently. I mean, the NIH budget for aging from the National Institute of Aging is about a couple of $1 billion, but only about 200 million is on mechanisms of aging. And the rest is on diseases of aging like cancer, heart disease. And just the cancer budget alone for the NIH is $6 billion. So we really not studied aging. And now with the advent of a lot of billionaires who don't want to die, there are literally billions of dollars being thrown into longevity research. And we're discovering the underlying mechanisms that are driving what we see as aging, which is really abnormal aging. In fact, aging is being redefined as a disease.
Wow. So aging itself
is
a disease.
In fact, the WHO has a code for aging as a disease. The current U.S. medical system doesn't have that, but we're treating all the diseases like whack-a-mole: cancer, heart disease, diabetes, dementia. And we're completely missing the fact that if we completely eradicated cancer and heart disease from the face of the planet, the number 1 and 2 killers, our life extension would be maybe 3 to 5 years. But if we address the underlying causes of biological aging, and that's distinguished from chronological aging. I can't do anything about when I was born. I was born in 1959. It's my birthday. I'm going to keep getting chronologically older, and that's fine. But my biological age is something I have control over. In fact, can reverse. And so scientists are now unpacking what the underlying mechanisms are that drive biological aging, that then result in the diseases of aging. So rather than treating all the diseases of aging, which we're now doing and spending billions of dollars on managing them, treating them, finding mechanisms and drugs, and just spending an inordinate amount of money. I mean, we spend in America $4.1 trillion in healthcare. About 80% of that is for chronic disease, and most of that is almost completely preventable and mostly reversible. So we now have the ability to unpack what I would call the natural laws of biology. Einstein said, I'm not interested in the spectrum of this or that element. I'm interested in the thoughts of God. The rest are details. So in a way, we're getting to look into the mind of God and understand through the radical exponential advances in science and medicine, which, by the way, have not reached your doctor's clinic or office, still practicing 19th and 20th century medicine.
Crazy.
We are finally understanding how the body works in order to create health. So we have a system of medicine that is focused on treating diseases. There's a book I read in my second year of medical school, which all medical students get, called The Pathologic Basis of Disease. But what is the scientific basis of health? I never took that class. I had no clue until I began to unpack functional medicine, which I was forced to through my own sicknesses. And I've had to really learn from the inside out. And then I've learned with tens of thousands of patients over 30 years how to apply this model. And so Young Forever, my new book, is essentially taking a look at the current landscape of longevity science and what scientists are talking about as the hallmarks of aging, the underlying things that go wrong as we age that underlie all disease. And layer on top of that the lens of systems biology and functional medicine, which takes it to a different level. Because if we sort of focus on the hallmarks of aging, and we can unpack what those are and try to find treatments or drugs or interventions to treat those, it's better than treating the diseases, but it still doesn't ask the fundamental question, which is why. So functional medicine is the medicine of why. Conventional medicine is the medicine of what? What disease do you have? What drug do I give? Not why. What's the mechanism and cause? So functional medicine is all about causes and mechanisms. So hallmarks of aging are these things that go wrong in our body, like mitochondrial dysfunction and DNA damage and epigenetic changes and abnormal proteins and telomere shortening and microbiome changes and inflammation and altered nutrient sensing and a whole host of zombie cells, all these things that go wrong. And it's important to know what those are, but what's causing those?
Yeah.
And that's what functional medicine is. It's a model for thinking about how to navigate the landscape of your health and create a model of treating people that is very different. It focuses on activating your ancient healing systems in your body. Our bodies have an innate healing system. You cut your skin heals. Your body knows what to do. You break a bone. I mean, I broke my arm a few years ago. It knows what to do.
Yeah.
Okay. That system is embedded in us. So all we have to do is learn how to activate these longevity switches. And that's what Young Forever is about. It's about taking the model of functional medicine, systems biology, network medicine, whatever you want to call it, and applying that to the science of longevity and create a really practical strategy through lifestyle and some cool interventions like hormesis and various nutraceuticals and maybe even some medication to activate these ancient longevity pathways and reverse our biological age. And I just did mine not too long ago when I was 62, chronologically, but I was biologically 43.
Damn.
So how old are you now, Max?
I just turned 40 recently.
Okay, so I'm a little older than you, but not by much.
Not by too much.
But let's say your biological age, we'll find out.
Yeah. So how do you determine?
I'm working on getting to 25 though, but we'll see.
Nice. I'm sure you'll get there. How do you determine your biological age? Because you're not like a tree that you just slit open and see count the rings, right?
Yeah, just you cut your arm in half and you look at that. The size of this is really relatively new. Steve Horvath, the scientist who created something called the epigenetic clock. And this is a measurement of patterns of alterations to your DNA that happen throughout your life based on the exposome, the full sum total of all the exposures of influences on your life, your diet, exercise, stress, your thoughts, your feelings, toxins, your microbiome, everything you could think of that's washing over you at every moment is regulating this framework of your DNA called the epigenome. So your genes are fixed. You've got 20,000 genes. You can't really change that. You know, you can edit them maybe in CRISPR and some fancy new technologies, which is fine. Maybe that's cool for different gene disorders, but they don't really change. But what changes is the gene expression, which genes are turned on or off, and how they're expressed over your lifetime. And that's controlled by the epigenome. Epi means above. So the epigenome is above your genes, and it literally is the conductor or the piano player. So your genes are like the keyboard, right? You've got 88 keys on a piano, but that can play jazz, ragtime, blues, reggae, whatever you want, rock, but classical, right? Beethoven, Mozart. But the piano player is the epigenome. So the epigenome is like the piano player. So you can control your epigenome throughout your life by what you eat and exercise and supplements, what you think, so many different kinds of ways to do it. Hormesis, we'll talk about. And so we now have a doorway to understand how we can influence our epigenome and how that epigenome can be measured and track our biological age. So Horvath determined that there are certain DNA methylation patterns that correlate with biological age. So we now can measure those through a blood test and track your biological age. So we have a metric for the first time to look at interventions and how they work to affect your biological age. For example, Kara Fitzgerald and her group looked at a very intensive functional medicine-like intervention of diet, not just your average Mediterranean diet, which by the way reverses your biological age, but a upgraded diet. Let's call it, the genius diet, whatever you want to call it, which essentially is a phytochemically rich, high fiber, detoxifying, anti-inflammatory diet combined with a few lifestyle strategies and extra phytochemicals. And they were able in 8 weeks to reverse biological age by 3 years.
Wow.
Just by doing that type of intervention. And then we haven't even layered on all the other cool stuff. So it's, there's the foundation you build for longevity. And then there's all the cool stuff we can add on top of it, which we can get into, which are the sort of advanced longevity innovations, some things that are like hormesis and ozone and hyperbaric oxygen and exosomes and peptides and transfer plasma exchange, which is kind of cool, or what's kind of related to parabiosis, which is where they hook the blood up.
Like a younger mouse, right?
Yeah, young mouse to an old mouse, and the old mouse becomes young. It's kind of cool.
Are they doing that in humans yet?
Yeah, I was going to ask you that.
Or like, I
have a lab tech. We're going to just hook up your circulation to mine. I'm going to suck your blood out, and we're going to. No, it's not happening. Although there was an episode of this TV show. I think it was a Silicon Valley TV show called Blood Boy. It's where they got this young guy to come in and give his blood to an old guy, kind of like Peter Thiel. I think he's doing that.
That's some like
Mal used to get transfusions from the blood of young Red Army soldiers to keep himself young.
God,
but you don't have to do that. Actually, the research shows that you can just clean your blood in the same way. It's not the things from the young blood that are making the old mouse younger. It's things from the old blood that have to be taken out to make the old mouse younger.
What do you think are those compounds that are being taken out, like inflammatory cytokines? Yeah,
exactly. Inflammatory products, damaged proteins. Your blood carries like thousands and thousands of molecules, and often these molecules degrade as we age, and certain things happen, for example, like zombie cells, which create cascades of inflammation throughout your body and accelerate aging. And so you clean out old damaged proteins, old damaged cells, you clean out inflammatory cytokines, all kinds of abnormal compounds that are generating inflammation throughout your body and accelerating aging, which is often referred to as inflammaging.
Inflammaging. So inflammation really is one of the potential cornerstones.
Absolutely, it's one of the hallmarks of aging, and there's 10. I think the first group of scientists talking about this talked about 9 hallmarks. I added one called the microbiome because I think it's a huge factor, and if you look at the data, it really plays out. But inflammaging is both a cause and a consequence of all the other disturbances in the hallmarks of aging. So it is a fundamental phenomenon that happens as we get older. We get more inflamed, and it's sterile chronic inflammation. It's not like a sore throat or a fever you get from a virus, but it's this sterile inflammation that it wreaks havoc in your body and causes all the age-related diseases. So every age-related disease you can name, heart disease, cancer, diabetes, dementia, and more, autoimmune disease, obviously, are all related to inflammation. And they're all caused by inflammation. And if you address inflammation, these diseases get better.
So how do we address inflammation?
Well, that's, people should read your book.
People should read your book.
But the truth is that food is the biggest modifier of our biology. It's the single biggest thing we interact with every day, which are the pounds of food that we put in our bodies. And that food can either enhance your health or degrade your health. It can either increase inflammation or decrease inflammation. It can either enhance gene expression or damage gene expression. It can cause hormonal regulation and balance or dysregulation, and on and on. So we have the power to influence our biology through the information in food. And a lot of people are talking now about this concept of the information theory of aging. David Sinclair talked about this, one of the Harvard researchers in longevity, who wrote Lifespans, great book. And this concept is that it's an information problem. And we have the wrong information floating around in our bodies. And if we fix that information, we create health. And the inflammation is really a huge factor in the disturbances that go on. And when we exercise, when we eat whole foods, when we eat a lot of phytochemicals, when we get rid of sugar and processed foods, when we do things to restore our nervous system through relaxation, when we get adequate sleep, all these things help to reduce inflammation. And then there's obviously the use of supplements and phytochemicals and nutrients, whether it's vitamin D or omega-3 fats, and zinc. These are all anti-inflammatory compounds. And then, of course, there's all these kind of cool advances we're learning about that are hormetic therapies. Hormesis is basically the idea that what doesn't kill you makes you stronger.
Love that concept.
So I saw outside you had a punching bag. That's when you get upset. You're like, my genius life isn't going so good, so I'm just going to hit this bag.
Yeah, when I get attacked on social media, I go out there and I take it out.
Oh, there you go. I don't even look at social media.
Smart. Social media, that's one way to accelerate aging.
Oh my God.
To spend too much time on social media.
Yeah, and definitely don't read the comments.
Definitely don't read the comments.
And so exercise, is a form of hormesis because you're harming yourself in a sense. You're tearing your muscles, you're lifting weights, but then your body responds by activating these ancient systems of healing and repair.
Wow.
So this is really one of the exciting frameworks of understanding longevity, which is the body has its innate, endogenous, or inherent mechanisms for repair and healing and restoration, and we don't know how to activate those in regular medicine. So functional medicine is about how do we activate these ancient healing systems in our body to do the work. Like when you cut your skin, it heals. You don't have to think about it. But we're doing everything to impair our healing systems. Everything we do in our modern life, the food we eat, the lack of exercise, the amount of stress, the lack of good sleep, the exposure to environmental toxins, the medications we're on, the microbiome stuff, all of this is just causing havoc and undermining our ability to activate these ancient longevity pathways and longevity switches and these repair mechanisms. So that's really what the book is about how do we learn how to do this in simple, practical ways that are very inexpensive, that we most have access to, and then what is coming down the pike. What are the innovations now that are out there if you want to explore? And then what are the things that aren't here yet, but that are on the horizon?
Yeah. What does aging currently look like for the typical American? And how do you see it like potentially looking if one were to follow, for example, all of the recommendations that you make? Like what is the best case scenario for aging today?
Well, I mean, the worst case is what we're seeing right now in America, right? The worst case is as you age. I mean, I remember when I was like a kid, I'm like 60 seemed like an old man. I'm like 63 next week. And I'm like, I'm going surfing next week. I'm going horseback riding. I'm going heli skiing. I'm like, it's not exactly what the average, 63-year-old was doing when I grew up. And my body composition is 6%. My energy's good. I think I had a bunch of friends of mine who are in their 30s, and they're all chatting this on. How do we get abs like Dr. Hyman? And I'm like, and it's not by exercising all the time. I don't exercise all the time. It's by understanding how to hack your biology to upgrade your biological software. And so what aging can look like is very, very different. And I just got back from Sardinia and Icaria, which are the two of the blue zones, where I was researching my book on longevity. And it was just amazing. This guy, Pietro, who's like 95 years old, upright, super strong. He just literally retired from shepherding, where he was, herding his sheep 5 miles up and down these very steep, rocky mountains all day long for 90 years.
Sounds exhausting.
No, he was like so fit. And he was singing me these songs, bellowing in a loud voice. I mean, you just don't see that. He gave me a super strong handshake. His eyes were clear. I'm like, wow, 95 ain't what it used to be, right? And so when you see people who have by default lived a life that activates longevity pathways, the body can respond. And that's what I think looks like. So I'm counting on, being strong and fit and healthy, to be over 100 years old. Peter Tia talks about the centenarian Olympics. I think he's changed the way he talks about it. But essentially it's this idea that how do you train for being a healthy 100-year-old person, right? What do you have to do? And it has to do with really fine tuning and optimizing your systems. And the truth is that, look, when you're 30 or 20, you can get away with a lot. But when, if you have a Toyota Camry that you drive off the lot and it's brand new, you can run that thing pretty good for a decade and not even change the oil probably. Yeah. But if you have a 1936, Mercedes or a Model T Ford, it'll run, but you got to take a lot better care of it. And so that's what happens as you get older. You have less wiggle room to deviate from, optimal practices. And so optimizing your diet, optimizing your exercise routine, optimizing your nutritional supplements, taking advantage of some of these longevity therapies. I just went to my friend Matt Cook at BioReset Medical, and I had a whole longevity day where I basically did plasmapheresis. I sucked out my blood, I cleaned it out, all the plasma went through away. I ozonated the blood when it went in. I had exosomes, I had peptides, I had all these IV phytochemicals like resveratrol and quercetin and ECGC, which is green tea extract. So literally, I'm kind of just experimenting with myself. And I was like, wow, this is really amazing.
Wow. Have they compared that therapy to like parabiosis? Like you took out your...
Yes. So just to kind of loop back on that, these experiments of parabiosis are essentially taking the circulation of a young mouse and hooking it up to an old mouse. And then they follow the phenomena of aging in the old mouse. And the old mouse becomes young by all these objective markers. And then they were like, well, wait a minute, maybe it's not the young blood that's causing the benefit, it's something else. So they said, well, let's sort of do an experiment where we do plasmapheresis on the mice. So we basically filter their blood, clean out the bad stuff on the old mice. And it created the same benefit.
Wow.
So I don't really have to hook my blood up to your blood.
To mine?
No, I'm good.
Thank God. Wow.
I can just go get a treatment once in a while and clean out my blood and rejuvenate my body. And so I'm actually tracking my biomarkers, not just DNA methylation, but there's an inflammatory clock we're going to be able to measure soon from the 100,000 Immunomes project from David Furman, which is super cool, looking at the immune age, where you can track other biomarkers like your insulin resistance, lipids, your inflammation levels, your hormone levels, your microbiome health, all these things you can track using biomarkers that are available today through traditional testing and through functional medicine. So I've created a longevity panel, a Young Forever longevity panel through Function Health, which is a new company that actually allows you to order your test by yourself. You don't have to go through a doctor. And I'm a co-founder and chief medical officer. And essentially we've created a panel that allows people to see what's happening over time, to recheck over time, and to get up to $15,000 worth of tests for less than $500, and to recheck the relevant things every 6 to 12 months and see how these interventions work. And we can measure your biological clock. We can measure 50 over 50 different cancers through a liquid cancer biopsy, through a blood test. And so there's all kinds of ways of tracking your health. So I'm very much into sort of understanding this on myself. Why not try it on myself? And then I sort of apply it to my patients. It's like how I do. I have a guinea pig, and then but it's all based on the science. So what happens from the bench to the clinic usually takes 20 years, sometimes more, right? And so often patients are not getting, and people are not getting access to information that's ready for prime time, but that just hasn't reached the clinic. And that's what I'm trying to do, is sort of close the gap on that.
Are you familiar with any of these technologies or these companies that I've seen sprouting up where they'll offer to do like full body MRIs? Do you think there's any value in that?
Yeah, I talk about that in the book. I talk about various advanced diagnostics that are both blood, urine, saliva, biosensors we can use, Oura ring, we track all kinds of stuff, but also imaging. So, to go get a total body MRI used to be like $20,000, $30,000. Now you can do it for $2,500. It'll probably be $300 within a few years. And that checks your body for all sorts of different diseases, including many cancers, and allows you to pick up things before they are relevant. So I had a friend who sadly was 50 years old, super healthy guy, and he had a family history of an aneurysm, and he kind of delayed getting a brain scan and ended up dying of a brain aneurysm at 50 years old, which would have been 1,000% preventable and treatable if he'd had a brain scan. So a lot of things can be picked up that are treatable early. And people go, well, I don't want to know, because what can you do? And I think the ostrich method of taking care of your life is not good. I think the more information, the more data you have, the better you're able to actually modify that. And that's what's important. Even genes can be modified. I mean, it's really quite amazing. Sickle cell anemia is a great example. I learned in medical school that this is what we call an autosomal dominant disorder. It's fixed. It's like Down syndrome or like Huntington's chorea, or, these are not things you can just like change your diet and fix, right? Yeah. Or maybe you can. So because all genes are impacted by what happens to those genes. So I was in a coffee shop, the Blue Bottle coffee shop in New York, grabbing a cup of coffee in the morning. This guy goes, Dr. Hyman, you saved my life. I'm like, I did? Okay, what'd I do? I'm like, well, I don't even know you. He's like, well, yeah, the African-American guy, he's like, yeah, I have sickle cell anemia. And I was in crisis every month, and I was really miserable. And I came upon your work, and I started following the diet and doing this and that. And like, I really am good now. I don't have crises. Maybe once a year I get a little something, but I'm really good. And a recent paper came out, I think it was in New England Journal, or maybe FDA approved, but using glutamine to help treat sickle cell anemia. And what happens with sickle cell anemia is the cells have a tendency, when they're under stress, to sickle, meaning they look like a sickle, which is what you used to use to cut wheat and stuff. Instead of being this round shape, they become this sort of weird sickle shape. And that basically scrapes in all the insides of your blood vessels and damages every part of your body. It's really horrible.
Wow.
But turns out it's related to a reduction in glutathione inside the cell. So glutathione is a natural product that your body makes to deal with inflammation. It's an antioxidant. It's a detoxifying compound. And it's made from 3 amino acids, glucine, glycine, and cysteine, which are pennies, literally pennies, to take this stuff. And they found that by using these compounds, they could modify the course of sickle cell anemia. Wow. So by upgrading his diet, he was able to upgrade glutathione by the recommendations that I make, because it's a lot of foods that we can eat, like the broccoli family or garlic and onions family. They help increase glutathione. Whey protein can do it. And my favorite is goat whey from regeneratively raised goats. So I think there's a lot of ways to upgrade glutathione. And that, in this case, can change the course of a very fixed single gene autosomal dominant disorder, which, in my training was just not possible, right?
Yeah. There's an interesting supplement or like a combination of supplements on the market that's been referred to as Glynac. It's a combination of equal parts glycine and N-acetylcysteine. Yeah. Which are, I guess, rate limiting in the production of glutathione.
Exactly. exactly. Yeah.
And they've shown like in clinical trials, there's some really exciting like work going on.
Yeah, it's amazing. I mean, I love glutathione. I shoot it up all the time.
You do? Love it.
I'm like a junkie. I don't put it on my arm. I
Shoot up glutathione.
I love it. Whatever I get.
So, okay, let's get granular with regard to diet, because within the context of longevity, there's a lot of debate about,
Here we go. Here we go. Okay.
Well,
I know where you're going with this. Let's go.
Protein.
Yes, I knew you were going there.
Protein, it's the most contentious issue, right? You've got researchers like David Sinclair, who you've cited, who I know I'm friendly with, but he'll argue that it's like low protein diets and I think specifically low animal protein diets that are the key to longevity, right?
Vegan diets are going to save us all, right?
Vegan diets are going to save us all, right? But then
save the planet and save humanity.
Right. All of that. And then there are some very brilliant people who I actually think are probably more correct in this, that argue that no, animal protein is the highest quality protein that you can find. And especially for older adults who tend to underconsume protein, they should be eating more animal protein.
Yeah.
So what's your take, Dr. Hyman?
My take is the Goldilocks approach. I think, we have these extraordinarily built-in systems to help us stay alive and to deal with both scarcity and abundance. And we need both, but not all the time, right? So if you just, for example, any therapy, like if you eat a huge amount of food, which we need to survive, you're going to become obese. Or if you don't eat at all, you're going to starve and die, right? So it's like, what's the Goldilocks approach? So what people are arguing about is this ancient pathway that's one of the hallmarks of aging, which is deregulated nutrient sensing. And there's 4 longevity switches that sense nutrients in your body. mTOR, insulin signaling pathways, which detect too much of stuff, like too much sugar, protein, amino acids, and AMPK and sirtuins, which detect a scarcity. And they do different things, but they all are involved in DNA repair and mitochondrial biogenesis and mitochondrial repair and antioxidant systems and reducing inflammation and doing all this really cool stuff that is activating our innate healing systems. So mTOR is what the crux of this argument about. mTOR is named after this compound that was discovered in Rapa Nui, Easter Island, in the 60s by scientists who were looking for compounds that could help us. So I don't know, people go, these are aliens who built these things. Maybe the aliens left us some cool drugs. It's actually pretty cool. But basically, they scraped this stuff up and they went to the lab and they, maybe it's an antifungal. And it didn't work so good. Let's put it on the shelf. Or let's study it again. Well, maybe it seems to modulate the immune system. So it's actually used in transplant medicine. But then they looked at other mechanisms. In fact, this pathway is named after this compound, which is rapamycin. So it's mammalian target of rapamycin. And it's in every cell. And this mTOR pathway is important because one, it helps you synthesize more muscle. And muscle is the currency of longevity. You lose muscle, you lose life. Sarcopenia, which is something nobody almost talks about, is this disease of muscle loss that happens with aging. So you could be the same weight as you were at 20 when you're 70 or 80 and be twice as fat, meaning you have marbled fat and it's dysfunctional muscle. It's muscle that's driving inflammation, that's driving hormonal dysregulation, that lowers testosterone, that causes insulin resistance, that screws up your cholesterol, that causes your growth hormone to go down, your cortisol to go up. It's a disaster. So you need to build and maintain muscle as you age. And it's critical to longevity for many, many reasons. If you don't activate mTOR, you can't build muscle. If you exercise, you activate mTOR. Well, I don't think anybody's going to argue that exercise is good for longevity, for heart disease, cancer, diabetes, dementia. Like it's just, nobody can argue with that. The science is so robust on this.
Yeah, that it's great for all of those
conditions.
Right.
So if mTOR is activated by exercise and mTOR is bad, shouldn't we stop exercising? No, right? So, but on the other hand, if you exercise all the time, you're going to kill yourself, right? If you just do too much, if you do a marathon, it's actually bad for you. It suppresses your immune system and you kind of deplete your whole system. So you want to activate mTOR in the right time, in the right way, but you also want to inhibit mTOR. So the argument about being vegan or avoiding animal protein is animal protein activates mTOR the best. And it's high in an amino acid called leucine and other branched chain amino acids, which are the rate limiting amino acids for building muscle. So if you don't have these amino acids, you can't turn on the protein building switch in your body. So you can eat all the protein you want. If it's low in these amino acids, you're not going to build muscle. It'll just be burned as calories. So you have to learn how to get the right kinds of protein at the right time. And then you have to also inhibit mTOR in order to activate this critical process of cleanup and repair. So imagine like just cooking in your kitchen and never washing the dishes.
Yeah.
It's gonna be a freaking mess after a while. So you need to make the food, but then you need to like clean up.
Yeah.
So that's what your body has. It has this amazing construction crew and this demolition crew and cleanup crew and repair crew and recycling crew. So we have that system. It's called autophagy, which means self-cannibalism. So we have hundreds of genes that regulate starvation because it was something we were used to having throughout history of evolution. We didn't have abundant food like we do now, or in every corner you can buy thousands of calories and eat them in 3 seconds, right? So we didn't have that. So our bodies don't really have a lot of genes to deal with that, but they have a lot of genes to deal with starvation, scarcity. So when that happens, you have to do all sorts of things to activate your survival mechanisms, and these are the longevity pathways. So you activate your antioxidant systems, you shut off inflammation, you recycle old tissues and proteins and cells, you increase mitochondrial function, you increase cognitive function because you want to figure out how to find your next meal. So you need to be sharp and mentally clear.
Yeah.
So all these wonderful things happen when you inhibit mTOR. So the best way to do that is by eating only during a certain window of time. Like 12 hours should be the minimum between dinner and breakfast. That's why they call it breakfast. Break the fast, right?
Yeah.
12 hours is not hard. You eat dinner at 6, you eat breakfast at 6. That's not so hard. Or if you eat dinner at 6, you eat breakfast at 8, that's 14-hour fast. And you eat at 10, that's a 16-hour fast. Not so hard. That gives your body a chance to clean up and repair. And then on a fasted state, you want to actually increase protein intake of high quality protein, ideally after exercise. So in my book, I talk about this review that was done by the world's leading protein researchers. So I'm not a researcher primarily. I mean, I've done a fair bit of research at Cleveland Clinic, but these guys are the gurus, and all they do is study protein, and that's what they do. And they got together and created a consensus paper looking at all the science, and they said, what does the data show? And it shows very clearly that if you give protein after exercise in the right amount, it actually will stimulate the most protein synthesis. So having, depending on your size and your weight and so forth, anywhere 30 to 50 grams of protein on a fasted state after exercise within an hour or two is the best way to accelerate muscle mass and building. And that's what I do. I work out in the morning and I have a protein shake. It's pretty easy to do. And I think one of the best sources of available amino acids is whey protein and particularly goat whey. And I'm not a big fan of dairy, but I think regeneratively raised goats are quite good in terms of the quality of the protein and the ability to synthesize muscle. And it's just a great hack. Goats get, you're not killing the goats, you're just milking them. And I think so you have to learn how to activate mTOR in the right time and have protein at the right time. And what happens also as you get older, and even the studies that show that maybe less protein early on is better, all of them show that as you get older, it's not better. And in my book, I tell the story of Emma Morano, who was died at 117 years old, an Italian woman. When she was 90, she was dwindling, and her doctor said, I want you to do 150 grams of meat every day. I think he said raw meat. And she did. She started in her 90s, and she lived to be 117 years old.
Wow.
So is it because of that or something else? Obviously we don't know, but most people have what we call anabolic resistance. As they get older, it's much harder to build muscle. So you need to work harder. You need to have more protein. And so you need to overcome that resistance. Now, you can get 30 grams of protein from many sources. For example, if you have 30 grams of protein, that's like 4 ounces of chicken or meat, or maybe 5 or 6 ounces of fish, but it's like 6 cups of brown rice or 2 cups of beans or 4 cups of quinoa, whatever.
Yeah.
That's a lot. So if you're eating all those grains and beans, one, you can't do it.
Yeah.
Right? You just can't physically do it. There's not room in your stomach. And so it's very tough to meet those requirements. Now you can mix animal and plant proteins. You can jack up plant proteins. So a lot of people, I see these like incredible bodybuilders who are like vegans and like they're bulked out. I'm like, what's going on with you? What do you eat? And I, dig into it a little and they go, oh yeah. Well, I have like, 14 protein shakes a day. No, I'm exaggerating, but they have all these jacked up protein shakes. So
Definitely.
you can add amino acids. And if you're vegan and you're committed for moral reasons, that's okay.
Yeah.
I have monks who are patients and that's fine. But I make sure they actually add amino acids. And you can do that through supplemental amino acids. You can add that. There's certain protein shakes that are vegan now that have added jacked up amino acids and branched chain in them already. So there's lots of ways to do it, but you can't avoid the fact of biology. And you to think that you have to inhibit mTOR all the time is just a bad idea. So rapamycin is now being studied, and it's one of those drugs that is being used to enhance longevity. And in animal studies, it's very promising. And there's a lot of biohackers and longevity scientists who are actually taking rapamycin as a longevity hack. And the question is, what's the dose? How much should you take? Is it good? Is it bad? I think we're still figuring that out, right? But I think it's an important strategy for regulating mTOR as we get older without having to starve yourself. So it sort of mimics calorie restriction rather than having to starve yourself.
Fascinating. Yeah, I mean, I love when you said that muscle is the currency of aging. Like I've come across a few studies that have actually shown that the amount of muscle mass a person carries predicts their lifespan.
For sure.
That it predicts longevity. And if that is indeed the case, then you should be resistance training regularly, and you should be consuming adequate protein to optimally support that effort.
Absolutely. And that's true, but that doesn't mean eating protein all day, all the time. It means having throughout the day adequate protein for your needs at the age you are, and at the same time also using strategies that inhibit mTOR, like time-restricted eating, or maybe certain food compounds, the phytochemicals that do that, or maybe even rapamycin. So there's a lot of ways to do it, but you can't avoid the fact that biology. People I often say you don't want to let your ideology trample over your biology.
Right.
A lot of people have beliefs about what's good or bad, but biology is biology. And there's a lot of data on this. It's not something I'm making up. I mean, I'm agnostic. I was a vegetarian, vegan for over 10 years. And I have a picture of myself when I was 40 and now, and you're like, wait, it should be reversed, right? I was kind of scrawny and I wasn't overweight, but I didn't have a lot of muscle. And now, not even like doing much. I do bands maybe 3 times a week, which is not that much, for half an hour, right?
Yeah.
And I'm like, it just looked like a totally different human being. Now we can throw that slide up. I'll send you the picture if you want.
I want to see it. So in terms of like a protein target, like in terms of like actual numbers.
Yeah.
Like,
so let's talk about it. So we have this thing called the RDA, recommended dietary allowance, or RDI. These are numbers of amounts of nutrients that we should be consuming on a daily basis to prevent deficiency disease. These are not the optimal amounts needed for health. So how much vitamin C do you need to not get scurvy? Not very much. 60 milligrams.
Right.
How much vitamin D do you need to not get rickets? 30 units. How much vitamin D do you need to not get osteoporosis and build your immune system and prevent COVID and do all sorts of things? Maybe 5,000, right? So and Robert Heaney, was a vitamin D researcher, wrote a beautiful paper called Long Latency Deficiency Diseases, which was based on the idea that we actually need more of certain compounds than we think, because in the short run, if we don't have enough, we'll get a deficiency disease. But in the long run, if we don't have higher amounts, we'll end up with this long latency deficiency disease like cancer, heart disease, and so forth. So the amount of protein we need, according to the RDA, is 0.8 grams per kilo, which most people are getting, but that doesn't speak to what your optimal needs are. And so depending on your activity level and your age, you might need 1.2, 1.5, even 2 grams per kilo. If you're a very physically active elderly person, you might need up to 2 grams per kilo, which is a lot of protein. So like, 30 to 50 grams, 40 grams per meal is a reasonable amount. And that's kind of what I shoot for me. But I think depending on who you are, if you're, Shaquille O'Neal, or if you're, Dr. Ruth Westheimer, you're going to need different amounts of protein, right? She's like 5'4" at 11 or something.
Well, you multiply it by your like ideal weight, right? So it's like, that's obviously gonna be different for every person.
But by your actual kilos. So I'm like, let's say 75 kilos or whatever I am. I multiply 75 by 1.2 or 1.5 and I can come up with a number.
Yeah. Super great.
And protein grams are like, people, what's a gram of protein? Like in my book, I go through what 30 grams is so people can get a sense of it, but it's not really that much. It's like, and the easiest way to figure it out is, if you're 4'11", then the size of your palm is pretty small. But if you're Shaquille O'Neal, the size of your palm is pretty big.
It's a big palm.
So you got to eat about a palm-sized amount of protein if it's animal protein.
Yeah. Okay. So I like that. So your
by the way, quality matters, right? So protein isn't protein. So feedlot cow is not wild elk or regeneratively raised animal, right? They're very different in the composition of their meat in terms of inflammatory triggers, in terms of fatty acids, in terms of nutrient levels and antioxidant levels, and a whole host of different things, phytochemical levels that are now found in regeneratively raised meats and animals that are eating a wide variety of plants. So it's really important to understand that the information in the food is also really important.
Yeah.
And I was in Sardinia, they know that they feed their goats and their sheep these wild plants at different times of the year because they know the meat and the milk are going to taste better. They don't know, oh, these phytochemicals in here that are going to make me live longer. Like they know that the flavor always follows the phytochemical richness of the food. And this one guy, Olinto, said, he gave me this entire like nose to tail pork meal. It was a lot. And he's like, we flavor the animal before we kill it. I'm like, what do you mean? He says, well, we feed it carob and acorns and this and that. And they know that what the animals eat matters. And so the quality matters.
Wow. So here I am just eating like grass-fed, grass-finished, but it's like the next level would be like herbs, feeding the animals herbs and acorns. And all kinds
there's
of
incredible metabolomic studies now done by Stephen Van Vliet and Fred Provenza. Van Vliet was at Duke. He's now at Utah State. And it's just remarkable to see the data on the using really advanced scientific analytics of metabolomic profiles and phytochemical profiles that we can measure now the difference between these animals and what happens.
It's amazing. But what do you do, Mark, if you live in like a food desert, or not a food desert, but like somewhere other than Los Angeles or New York City or Miami or Chicago or wherever, where we are lucky enough to have access to the most pristine.
It's tough. It's tough. I mean, this is really why it's not it's not an individual solution necessarily. And this is why I wrote the book Food Fix and why I started my nonprofit Food Fix campaign to drive policy change. So we literally helped to get $20 billion for regenerative agriculture in the IRA bill, the Inflation Reduction Act. So that was a huge advance. That money is going to be deployed to educate farmers, to help them transition, to support the transition from traditional to regenerative agriculture, which is going to allow the growing and raising of both plants and animals in a different way to restore the health of the ecosystems, restore the soil, draw down carbon, to increase biodiversity, to restore water systems, and to provide much more nutrient-dense, phytochemically rich food.
So all that is to say, you are not of the camp that advocates for low-protein diets for longevity at this point.
I'm like getting the Goldilocks thing. It's like you don't want to eat 50 ounce ribeye every meal, but I think you need it's like the right amount.
Yeah.
So I don't think it's a high protein diet. It's not like 50% of your diet should be protein, right? It should probably be like 20, 25%. And depending on your age, it should, it can be more as you get older, but it's not like a high protein diet where all you're eating is steak, or a carnivore diet. I'm not saying that. We need like a lot of phytochemicals.
Yeah. Going back to inflammation and other things that people should be avoiding to mitigate inflammatory assault, because this is so big and it's so relevant with regard to aging and aging well. What are some other things that people should be like looking out for?
Well, I mean, there's the obvious things, right? Diet, exercise, stress reduction, sleep, foundational stuff. But the stuff that I found so cool was this whole idea of hormesis, these kind of therapies that are available to us now that were just part of our life, right? We live in these perfectly controlled, thermoregulated environments where it's 68 degrees and we have like never exposed to any biological stresses, right? And historically, this wasn't the case. We had to deal with extremes of temperature and weather, and we were out there like the animals in the woods when the weather's shitty.
It was a struggle.
Yeah, it was a struggle. So what's happened is that we have embedded within us these pathways that can get activated by these biological stresses. So it's again the Goldilocks version. Heat and cold, for example. Too much heat and you're heat stroke and you're dead. Too much cold and you're hypothermia and you're dead. Right. So what's that Goldilocks version? So Hormesis is a really powerful set of tools, and some of them are really easy to access, like time-restricted eating, where we starve ourselves for periods of the day, exercise, another form through both interval training and strength training, resistance training. And then there's things like hot and cold therapies, which most people can access. I took a cold shower this morning, 2 minutes in cold shower. It's a good way to wake up. Don't need a coffee. And you could also, fill your bathtub up with water and throw some bags of ice cubes in there. You don't have to have a cold plunge. There's a lot of ways to do it. Or hot therapy, saunas, and there's sauna blankets now. There's infrared saunas. For a very low price, you can often get access to these things and use them at home, and they're great. So
you can also take a hot bath, right?
Hot bath.
Like if you've got nothing but a bath.
Totally. I actually, I like the bath where it's so hot you can barely get in. My girlfriend doesn't like that, so I get in first, let it cool off, then she gets in. So it's like there are ways to do it, and that therapy activates, for example, heat shock proteins. So one of the hallmarks of aging we talk about is damaged proteins. And damaged proteins happen because of all these insults, and they kind of muck up your system. And how does our body heal or fix these things? Through autophagy, like we talked about, but also through saunas. Saunas activate these proteins called heat shock proteins, which repair or eliminate these damaged proteins. And we know from data from Finland where they did these trials looking at sauna use. And by the way, there's enough saunas in Finland for everybody to be in a sauna at the same time, the entire population.
In another life, I was Finnish. I love Finnish sauna culture.
Yeah, so it's great. And also they would jump in the ice water too. So they had the both. But the control group was like 1 sauna a week, and then the intervention group was like 2 and then 3 to 4 to 5. So on the 2 saunas to 3 saunas a week, it was like a 24% reduction in mortality. And if you had 4 saunas or 5 saunas, it was like a 40-something% reduction in mortality.
Damn.
And it also activates your innate immune system, helps your immune system work better. It increases heart variability, increases circulation, helps with weight loss, detoxification, heart rate variability. I mean, there's so many benefits to it that help reduce stress. And I mean, I just love it. I mean, if I could do a sauna and cold plunge every day, I just like, it's my, I'm like in heaven. And then there, there's cold therapy, which is gaining in popularity, cryotherapy, cold plunges, ice cold bath, whatever you want to do, cold shower. Most people have a shower. And that actually also activates brown fat, improves mitochondrial function. It's a stress to the body, increases dopamine, clarity, function, and has so many downstream benefits. And they work through some of these ancient hallmarks of aging, these longevity pathways I was talking about. So that's something people can really easily do. There's more advanced ones that are a little harder to get access to, like hyperbaric oxygen therapy or ozone therapy or hypoxia therapies. These are therapies that actually, challenge the body. So we know, for example, that people who live at high altitudes, like the Ecuadorians in Vilcabamba, live a long time. They are very high altitude, and that creates inducible hypoxia, something. I forget the inducible hypoxia proteins or something. And these are other mechanisms in the body that help to activate these longevity switches. So you can use a $50 mask that you put on your face when you're sitting at your desk or when you're exercising to restrict oxygen flow. Athletes use this to increase their performance, because if you can, run a 4-minute mile at 10,000 feet, you're going to do great at sea level, right?
Yeah.
So that's kind of how they enhance their fitness.
I've seen it. They look like Bane masks.
Yeah,
Like the Dark Knight Rises.
It looks like it's got from the Silence of the Lambs.
Yeah. Sometimes you see these lunatics running up Runyon Canyon here in Los Angeles wearing these masks.
Exactly. So
I hate them.
And there's also this thing called the cell gym, which is a kind of an easier version where they put a mask on your face, sealed tight, and they take you down like up to Mount Everest for a short period of time where you're really starving for oxygen, and then they bring you back down. And that induces mitochondrial repair, cleans up all mitochondria, enhances mitochondrial biogenesis and function. So mitochondria are key to aging, and they're why muscle is so important, because that's where most of your mitochondria are. There's also hyperbaric oxygen, which is where you go into a tank, basically, which is a decompression chamber they use in scuba diving, where they take you down to 2 atmospheres or more. And that's basically like 66 feet below sea level. And they pump in 100% oxygen, which is another kind of stress because room air is 21%. And that induces all sorts of benefits to the body in terms of stem cell generation. And that's one of the things that happens with aging is the stem cell exhaustion. But it also seems to kill zombie cells. Zombie cells is another one of the hallmarks of aging. These cells that are not really dying, but that kind of live and never die, but spew out, inflammation, sort of like the fire-breathing dragon that's running around your body. And then it basically kind of infects, not literally infects, but it basically infects other cells, and they become zombie cells. And it's like it's like the zombie apocalypse right inside your body.
Damn.
And hyperbaric oxygen kills zombie cells more than anything else. So does, by the way, fisetin, which is from strawberries, which is another concept of phytohormesis. Phytohormesis is plant compounds that are a little bit stressful to our bodies. And these plant compounds were not designed by plants for our benefit, right? They were designed for their own protection.
Yeah, right.
But we use them, and we kind of co-evolve with these plants because our bodies are lazy. Like, if we don't have to make vitamin C, we don't make it. We get it from our food, right? So we don't want to do stuff that we don't have to do biologically. So we kind of co-evolve with these plants. So I was like, I'm getting all these phytochemicals from the 800 wild plants that I'm eating. I don't need to build mechanisms to actually create more vitamin C and so fisetin, for example, from strawberries also is a senolytic, which kills these zombie cells. Senescent cells means aging cells.
Wow.
And also the hyperbaric oxygen tank seems to increase telomere length. Telomeres is another one of those hallmarks of aging, the shortening of our telomeres. So the shorter your telomeres, these little end caps at your chromosomes that protect your chromosomes, shorten as we age and as your cells keep replicating. So when you can lengthen them, you actually improve your longevity. And many things lengthen them. A multivitamin, meditation, good food, a lot of things will fix it. But hyperbaric oxygen does it. So you can just lay in a tank and watch a movie, and you get younger.
Amazing. What was the term? There was a term that you coined in one of your more recent books, phytochemical symbiosis.
Yeah, symbiotic phytoadaptation.
Yeah, there you go. I love that.
So I just made that up years ago because I was like, wow, food is medicine and like food is information and what's going on here and how do these plants know? It's like, how do they know what to do? It
But
just
according
blew
to
my mind.
carnivores, these are the compounds that are making us sick. Are they wrong?
Well, actually, if you're eating wild animals, you're getting these compounds, and that's the benefit of eating these animals, right? So that's what's so amazing.
Right.
And this is the work of, like I said, Fred Provenza and Stephen Van Roulette. Fred Provenza has been on the podcast a number of times. Highly recommend his book, Nourishment, How to Reclaim Our Nutritional Wisdom from Animals. And it's so fascinating about how he sort of has been studying rangeland ecology and the interaction between soil and plants and animals and humans for 50 years. And this guy, I meet a lot of people. I know a lot of famous people, presidents, kings. Nobody kind of gets me excited. But this guy, I literally made a pilgrimage to Montana to go visit him because I wanted to meet him and talk to him. And he just has this beautiful philosophical view of the world, and his scientific knowledge is so deep. And he talks about this phenomena of these phytochemicals that are in all these animals that we've eaten forever. So even if unless you're eating like, feedlot animals, then, that's a problem. But if you're eating, animals that are eating plants, you're getting phytochemicals.
Yeah.
So it's all BS.
No, it's true. I actually looked at a paper recently because a carnivore sent this paper my way showing me that actually animal products like pasture raised beef, for example, is a source of phytochemicals.
Yes.
Who'd have thought?
Yeah, that's
I mean,
right.
you still get vastly more when eating produce.
Maybe. In fact, some studies show that, for example, these goats eating these different kinds of plants have as high levels of catechins, which are in green tea, as green tea.
Mm.
And this is what happened in Sardinia. These goats and sheep eat all these wild plants that have high levels of these catechins that then they get. And these are longevity compounds. So one of the longevity compounds that I recommend and take is ECGC, which is epigalactic-catechin gallate, which is basically a fancy word for saying the cool crap in green tea that makes you live longer.
Amazing. So just like eat more goat or drink more green tea, whichever
goats,
you prefer.
It depends what the goats are eating, right? If the goats are being fed in a factory farm, no. But if they're out there, eating all the weird things that goats eat.
Interesting. I'd love to look at populations that eat a lot of goat. I know in
that was
yeah.
Well, that was in Sardinia and Icaria. Those are shepherding cultures.
They eat a lot of goat there.
Yeah, goat and sheep. Yeah.
Wow, that's fascinating.
I mean, they didn't eat that much historically because they just couldn't afford it, so they would milk them, and then now. I met this guy, Silvio, and he's like, well, now we only kill the ornery goats and eat them.
Damn. So realistically, how long you think we're going to live? How long you think
what's
we have
the possible limit of human longevity?
Yes.
What am I shooting for? I'm going for at least 120, maybe 150, maybe 180. But who knows? There's a lot of people now talking about longevity escape velocity, like Ray Kurzweil and others, who are futurists. And this is sort of the idea of longevity escape velocity is that we're going to keep advancing our science in such a way that we're going to keep outliving death by these technologies that will help us extend life.
Doesn't worry you though?
It kind of worries me. I'm like, I don't know if I want to live to be 947 years old or,
you're putting your biology in the hands of technologists who haven't always had, your best interests
for sure
in mind, right? We're addicted to these freaking things, right?
But let's look at what may be more realistic. Madame Clément lived to be 122 years old. That's the longest known living human. There obviously are people who say they live longer, but I don't know if they have birth records or can count, or rishis in India who are 180. I don't know, but who knows? But anyway, she's the most well documented. And then Emma Morano was 117. And Madame Clément, she was a wine drinking, smoking chocoholic. So I wouldn't follow that plan. She had some probably good genes, but that's possible for most of us. And given the way we now understand science and what I've unpacked in my book, not just in a sort of explanatory scientific way, but in a very practical program that you can follow step by step that's accessible to most people now, I think we can achieve this. And so in animal studies, just taking that alone in terms of calorie restriction, which is just one intervention, which is sort of activating these longevity pathways that are related to nutrient sensing like mTOR, sirtuins, AMPK, and insulin signaling. it's been shown that alone can extend life by a third. So that for a human, that means going from 80 to 120. That's a lot. Okay, so I'm good with that. I think that's an achievable goal right now.
50%.
Right now.
Yeah.
Like if we addressed all the things that I talk about in the book, all these hallmarks, if we understood the causes, and it's not as easy as we think. Some things we have control over, right? Our food. I mean, even when you go to the best restaurant in America, or eat the best food in America, it's so different than the food, for example, that you get in Europe or on these islands or in these places where they're eating like in Icaria, they're eating wild greens, summer greens and winter greens and wild mushrooms and wild sage tea and all this stuff that we just don't have access to, right? So there may be limits to the quality of our diet. Exercise is available to everybody, right? And I think the certain phytochemicals we can use that are now being researched in longevity that I think are safe and worth a bet. Certain compounds like NMN are pretty exciting. That NR and NAD that also activate sirtuins and DNA repair and all these longevity switches that you can take. And then there's drugs that are being researched like metformin, which I'm not a big fan of, and I can go into that if you want, and rapamycin, which is being studied in animal trials and I think increasingly in human trials. So there's a lot of work being done in this area. And I think, without getting too extreme and using, crazy gene editing techniques and all the stuff, we're going to be able to get pretty far along using the foundational basics. And then there's all this kind of stuff that's coming down the pike, like, robotic nanotechnology that, can fix things inside your body with nanorobots and 3D printed organs and, replacement parts. Some of us need replacement parts, that's okay. Like, it's not a bad thing.
Yeah.
Sometimes if you got an old car, you need a new muffler, but it's okay. But I think what's exciting is it's a combination of these sort of basic foundational things combined with sort of advances in regenerative medicine, things like stem cells, exosomes, peptides, natural killer cell infusions, plasmapheresis. I talk about all this in the book that are basically emerging strategies that are safe and effective, and the costs are going to come down, and we'll be able to take advantage of these in ways that I think will have profound impact on our health and longevity.
Which pharmaceuticals are currently exciting you the most? I mean, you mentioned metformin. I know now a lot of people, it's actually quite topical, are talking about semaglutide as being like a really...
Ozempic, yeah.
Yeah.
Semaglutide is a peptide. Insulin's a peptide. There's, I think 80,000 peptides in the body. There's, I think 70 or 80 that are approved by the FDA for different uses. They're extraordinarily effective. And what are peptides? They're small mini proteins that your body makes. So your body has to communicate all sorts of messages inside of it to do its job. And so peptides are a lot of these chemical messengers that the body makes to regulate everything that we're doing, from our hormones to our brain chemistry to our sex drive, pretty much everything. And so a lot of these are being used now to treat various conditions like Ozempic. I think, again, I can take someone who's severely obese, who's diabetic, who has heart failure, who has all these chronic illnesses, and I can completely reverse all that without any drugs. Well, yes, I actually do use a drug, the most powerful drug on the planet. It's called food. And I think that tells me that while these things may be additive, they're not a replacement for doing this. So yes, people lose weight and they do better and they suppress their appetite, but I think it affects blood sugar control and insulin resistance, which is the fundamental driver of most age-related diseases. That's what's going on. It's like we're just flooding our bodies with sugar and starch. We eat about a pound a day almost of sugar and starch on average.
Wow.
Right, 155 pounds of sugar and 133 pounds of flour per person per year. That's according to USDA data. I mean, it varies from year to year, but it's basically a lot. And you add that together, that's a lot of stuff that we didn't consume before. So we might have 22 teaspoons a year as hunter-gatherers if we found a beehive or we found a bunch of berries. Now we're eating that every day.
Wow.
And so our biology is not adapted to that. And so anything that regulates insulin resistance will help with longevity, whether it's resveratrol or whether it's Ozempic or whether it's metformin, it'll all help. But the question is how help compared to what?
Yeah.
Right. So the old joke is the Vermont farmer was asked, "How's your wife?" He goes, "Compared to what?" So it's always compared to what, right?
Yeah.
So for example, a study I love to talk about is the diabetes prevention trial, which looked at pre-diabetics and trying to prevent their progression to type 2 diabetes. And they gave them either nothing, control group, lifestyle change, or metformin. The metformin did reduce the progression of diabetes by about 31%. Lifestyle, about 58% reduction. But the lifestyle intervention they did, when the study was done in the 90s, was the worst possible diet you could have for a diabetic.
Wow.
It was a low-fat diet.
Damn.
High-carb diet.
Wow.
Now, they did take away all the junk food.
Yeah.
So it was a healthier, low-fat diet. But they had them exercising and they were supervising them and they had group things and they had to track what they did. So there was a lot of other interventions. And I know some of the people in this study. And I was like, whoa, what if we took the work, for example, of Sarah Hallberg and others, where they did ketogenic diets, not in pre-diabetes, but in type 2 diabetes, and it completely reversed, not prevented, reversed type 2 diabetes with people who are on insulin for decades. Like, that's just mind-blowing, right? So what if we compared that diet to metformin? I think metformin would be like, maybe like here, and that diet would be like here. So I think it's compared to what? So
Yeah.
I think there's a large trial going on now called the TAME trial, targeting aging with metformin. And I think we'll see. I mean, I'm open-minded. I'm willing to change my mind when I see data, but it's not the first thing I recommend to patients. And I think the achievements that we can see through lifestyle interventions are so much greater. So I had a patient at Cleveland Clinic, Janice, who was part of our group model called Functioning for Life, which is based on the idea that group support helps you change your behavior. So we put her on a very anti-inflammatory, low glycemic diet, not keto, just more than 50% fat, but good fats, high fiber, phytochemically rich, basically a functional medicine approach. And, gave her group support, encouraged her to walk a little bit, a couple of vitamins, nothing expensive or super high intervention. In 3 days, she was severely obese with a BMI of 43. She had type 2 diabetes on insulin for 10 years. She had heart failure with an ejection fraction of 30%, which is like she's on her way to a kidney transplant and a heart transplant. Her kidneys were failing. Her liver was fatty. Her high blood pressure was high. She was on a pile of meds. She was on her way out at 66 years old. 3 days, she was off her insulin. Her A1C went from 11 to 5.5 in 3 months. She got off all her medications, reversed her heart failure, which, by the way, doesn't happen, right? Reversed her kidney failure, which, by the way, doesn't happen in traditional medicine, right? It's just once you got it, right?
Mm-hmm.
You're going to manage your disease. We're not going to get rid of it. There's a whole idea of chronic disease management, which drives me crazy because I don't want to manage it. I want to get rid of it.
Yeah.
And within a year, she lost 116 pounds, got off all her medications, and biologically was a totally different person.
Wow.
At 66. So even if you're really far down the pike and like near death, that's how powerful food is. So she could have been every single drug you could imagine, Ozempic, metformin, rapamycin, everything.
Kitchen sink.
If she had done all of that and not done the food, she wouldn't have seen that change.
Wow. Yeah, it's true. Even semaglutide, people are talking about as like a revolutionary weight loss drug. Obese patients losing like 20%. They gain it right back when they come off the drug.
Of course.
Because they hadn't built the healthy habits, right?
Yeah.
They hadn't changed their diet. So they're just using the drug as a crutch. And then as soon as they come off it, they gain it all back.
Yeah. You can lose weight with chemotherapy.
Yeah.
I think that's not the good strategy.
Exactly. Wow. So important. I don't want the Secret Service coming after me, but you were recently at a White House conference on nutrition. So I have to ask, like, what are the kinds of things that you all talked about?
Well, this is something we've been working on a long time. I think my colleague Daria Mazafarian from Tufts was a big proponent of having this conference. The last one was 53 years ago under President Nixon. And a lot of our nutrition policies are dating from that era when there wasn't the rates of obesity. There was more hunger, more starvation. So food stamps and WIC and all these programs really came out of a lot of that work. But nutrition policies have not been updated in over 50 years. So we advocated and lobbied for this. And, I've been, having much to sort of my dismay become a lobbyist and go to Washington, meet with congressmen, senators, the White House, the USDA, HHS, and advocate for the science and for the patients and to change our policies so that we can reduce healthcare costs, improve healthcare outcomes, and actually apply what we know works. And what was really encouraging to me was that there was a lot of work done, the pre-work done. We were involved in a lot of pre-work in our team. And the White House presented a national strategy on nutrition. And it was the first time that's ever happened. It was a very detailed strategy. And of course, it was, wasn't the full Monty like I would have liked, but it was a real step in the right direction to try to address some of these issues by, focusing on the idea that food is medicine. This is the first time I ever heard in a government setting that food is described as medicine. There's a bill in Congress, for example, for medically tailored meals, which hopefully will pass, and that will allow us to prove that food works better and we should pay for food instead of drugs.
But like, what kind of foods would they, what would they recommend, for example?
It would be foods that actually help to reverse these chronic diseases, which we know how to do. So the devil's in the details. But even if the government doesn't do it, the Rockefeller Foundation now is funding $250 million study of food as medicine for chronic disease and medically tailored meals. So there's a lot of stuff happening. We're talking about, changing food labels and addressing food marketing issues that are problematic and having nutrition education for doctors. Amazing concept, right? Isn't that a brilliant idea?
Definitely.
And having changing our dietary guidelines to update the science to include the science on low carbohydrate diets. I met with the head of both the USDA and HHS who are in charge of our dietary guidelines. And I said, look, and they were very open. And I said, look, these are called the Dietary Guidelines for Healthy Americans. That is 6.8% of the population.
Right.
So how about we include recommendations that help people who have metabolic problems?
Yeah.
And 93.2% of Americans, according to new data, have some level of poor metabolic health. High cholesterol, blood pressure, blood sugar, have had a heart attack or stroke, or are overweight. That means 6.8% of the population don't have those things. And those are all signs of poor metabolic health, AKA insulin resistance, prediabetes at some degree, right? And they're in that continuum from optimal to prediabetes. So it's not like you're healthy and then you get prediabetes and then you get diabetes. It's like a continuum. So you can intervene along that continuum. So there's a lot of exciting things that came out of it. And I'm having a meeting on Friday with the USDA, and we're continuing to work with congressmen and senators on policies. We got a report done from the Government Accountability Office, which took a couple of years to be done. But essentially, I work with my friends in Congress, and I said, hey, this is silly. There's all these agencies, all these departments, all these food policies that are totally in opposition and contradictory to each other. So we say with the USDA dietary guidelines that we should limit our intake of sugar. At the same time, we spend $750 billion on SNAP program or food stamps, and 10% of that is for soda.
Yikes.
So how does that comport? If we're saying don't eat it and we're paying for it, and there's example after example, right? So I said to them, we need to sort of update our guidelines to address these discordant things. And so the Government Accountability Report came out, and it said, and it was worse than I thought. It said there are over 20 agencies with over 200 policies, agencies, departments, whatever, with 200 policies, most of which are uncoordinated, often working at cross purposes. And it was the first report done on chronic disease and nutrition. And it didn't even include all the collateral stuff around, the effect on health disparities and the environment and the way we farm and the food, all kinds of issues. But it was just like focused on chronic disease and nutrition. And they recommended for a federal entity to be established to coordinate all these efforts and to solve these problems. And in the appropriations bill that's now in House, it should pass the Senate. We have a provision for creating this entity within the government to establish this interagency task force to address this and start to coordinate these policies and deal with these inconsistencies. And then there was a $2 million appropriations for the food as medicine pilot. And so there's also a medically tailored meals bill in Congress now, which we're working with Jim McGovern, which is $500 million, 20 centers, 10 states, really to do a very aggressive pilot looking at food as medicine interventions for chronic disease. Now, there's a lot of data out there. It's not like there's a lack of data, but the government likes to see their own data. So it's fine. It's fine. Whatever it takes, it'll take time, but it'll happen.
But the government has typically been fairly fat phobic with regard to animal sourced fats, right? It's been the guidelines have typically been very generous with their recommendation for grains and grain products, right? Yeah. I mean, even and he's a great researcher. So this is not personal, but Darius, Mozaffarian, I had a conversation with him. You must be familiar with the food compass.
Yes, I know about some of that. I know where you're going with this, but go ahead.
Right. So I'm just curious, your take, because you were in the room where it happens, so to speak. In
the room where it happens. That's from Hamilton.
Hamilton,
get the reference.
Hamilton chef. So, do you think that there's a world where we're not just going to see more of the same like, the endorsement of like ultra processed foods, or at least like a hall pass for ultra processed foods because of the
it's
power of industry?
complicated. I mean, it's complicated because there's so many competing interests and so much money. I think, processed foods are not bad, right? Sauerkraut's a processed food. Yogurt's a processed food. Canned sardines is a processed food.
Dark
right?
chocolate. Yeah.
So
Even ground beef.
Right. Ground beef is a processed food, but ultra processed foods is very different. Ultra processed foods essentially means the foods that are assembled from ingredients that you wouldn't have in your kitchen, right? That are extracted from industrial agricultural products like corn, soy, and wheat, that are made in a factory, that resemble and have all their components that have no food value, into these food-like substances of all color, size, and shapes that are extremely harmful to our biology. So I think you would not find any legitimate scientists, including Dari, who would say that they should be any part of our diet.
Great.
Yeah.
I hope that's true.
And I've had this conversation with him.
Yeah.
So
I love that. No, I trust you fully. I mean, I was glad when I saw that you were there, because I know that you've always been a champion for well-sourced animal products, and for, you're very progressive with regard to like low carb diets and time restricted eating, as we've talked about, all that stuff. So, hey, if you like that video, you need to check out this one here, and I'll see you there.
Safety and feasibility study. And that's the first study that we do, looking at, can others with secondary and primary progressive MS implement this complicated regimen that I use for my own recovery? Is it safe? Will they actually do it? And then what is the effect size?